Hi all, in this video I'm going to discuss the simple harmonic motion. Simple harmonic motion. Let's see what the simple harmonic motion is. To discuss the simple harmonic motion, I'll take this circle. The diameter is AB and the center is O. We will consider a particle which is moving on the circumference or on this circle. Now if we think about the projection of this particle, if we consider the projection of this particle, actually the projection of this particle is moving on this diameter from B to A, then A to B. Actually, it is an oscillatory motion repeated back and forth about an equilibrium point. What is the equilibrium point? Equilibrium point is O, the center of the circle. Okay, now we will go beyond that. To discuss more about the simple harmonic motion, I'll draw the AB here is a straight line. The center O is here. There is a particle which is moving on AB. The distance from O to the particle, I'll take it as P, is x. Then the velocity. Velocity is, we know that dx over dt. What is it? It is x dot. Similarly, the acceleration. D square x over dt square, or I'll denote it by as x double dot. Okay. However, if we think about more about this motion of the particle, it is a motion of a particle in straight line with an acceleration is always directed. Acceleration is always directed towards a fixed point in the line. Actually, the fixed point in the line is equilibrium point. Therefore, according to the definition, x double dot, the acceleration is directly proportional to x. That means x double dot is equal to negative lambda x, where negative sign. Why do I use the negative sign? Because the direction of the acceleration is always opposite to the direction of the motion of the particle. Since lambda is a positive number, then lambda, I'll take it as omega square. Therefore, x double dot is equal to negative omega square x. This is the first equation of the simple harmonic motion. This is called the characteristic equation of the simple harmonic motion. Now we know that x double dot is equal to dx dot over dt, or dx dot over dx times dx over dt. This is the chain rule in calculus. Okay, now dx over dt is x dot, therefore x dot dx dot over dx. Now I am going to substitute x dot dx dot over dx is equal to omega square x. Now if I integrate both sides of this equation, x dot dx dot omega square x dx. However, this is x dot square over 2. This is omega square. What is this one? X square on 2 plus c, where c is the integral constant. However, I'll consider the AB straight line again. This is A, this is B, and I'll take this distance as A. This is the particle. The distance from this one is x. This is x double dot. We know that at the point B, x dot is equal to 0, or the velocity is equal to 0. Now, if x is equal to A, then x dot is equal to 0. I'm going to substitute. This is 0, the left hand side, omega square A square over 2 plus c. Therefore, z is equal to omega square A square over 2. Now the above equation can be written as x dot square over 2 is equal to omega square x square over 2 plus omega square A square over 2. 2 can be cancelled. Omega x dot square is equal to omega square times A square minus x square. However, x dot is the velocity of the particle. Therefore, I'll take x dot is equal to let is equal to v square is equal to omega square A square minus x square, or v is equal to plus or minus omega A square minus x square, where since t increases, x also increases, v is always positive to this direction or to b. Therefore, v is equal to omega times A square minus x square. This is the other equation. This is one of the most important equations in simple harmonic motion.